All right, I'm here with Sandeep and
Anurag.
Anurag. So these are, I guess, co-founders of Polygon originally, but now Anurag is doing Avail. And Sandeep has some great news for us today about AggLayer, I guess, right? So let's pass around the mic already and let's hear it from you, Sandeep. What's new with Polygon CDK, with AggLayer? What are you excited about? What should we look forward to in the next month?
No, so with Polygon, I always say, and I've been saying to a lot of people that the real Polygon is about to be born. Till now, we have done a lot of things, but our mission to build the real, infinitely scalable, Web3 trustless internet, as I call it. I say Web2 is trustful internet, Web3 is trustless internet, and we want to build a network which can scale to that levels. And why I'm saying that Polygon is getting born is that architecture, after years of research and building and interacting with the developers and everything, we have finally found a place that okay, this is the architecture which scales it to the scale of internet. And that architecture is very simple. You have Polygon CDKs. You can launch hundreds or thousands of chains, but then you have a lot of fragmentation for the users, right? But what you do is you aggregate them back in one single layer or one single security zone, and all of these chains for the end user feels like one single large chain, right? That's the simple idea of Polygon and Polygon AggLayer. CDK plus AggLayer, CDK infinite scalability, AggLayer unified liquidity across the chains, and that's pretty much about it for Polygon. That is the end game of Polygon. Now we are at a stage where CDK is built out. You guys know, after months of hard times and all that, is now approaching some level of maturity, some level of stability. Plus we have the AggLayer, the V0, on Ethereum. Very soon the V1 comes out, and then you have the full version of Polygon in the market, and then we go from there.
Cool, nice, yeah. And indeed, at Gelato, we currently have the latest release of CDK, AggLayer, Unified LXY in production with Astar. So I guess for 2 months already, the AggLayer is in existence. So it's really cool that it actually works.
No, and I have to give a big shout out to the Gelato team that this was basically a rushed. We would have needed 1 month more to stabilize it, but they the A-Star team wanted to launch fast, and it has been really tough 1 month of calibrating a lot of things and this and that, and Gelato team has done a really good job in kind of making sure that it's up and ready and uptime and all that for the clients. So yeah, big shout out to you guys also for that.
Thank you very much, and it's been a pleasure working with you, absolutely. And yeah, I mean, we had a super stable test, and it was just this new AggLayer release, which is still a bit unstable, but it's stabilizing. I think the last weeks have been super solid, and yeah, super excited. I think for May when the production release will be out the door. Cool.
Hopefully.
So yeah, Avail is launching on mainnet, I think May as well, right? So what are you excited about? What should we look forward to here, and how do you think you set yourself apart from the other DA layers that are already on the market today?
Yeah, I'm pretty excited about Avail getting to mainnet. We've been developing Avail DA since 2020. Some people might not know, but we started Avail within Polygon back in 2020, and we spun out of Polygon back in March last year. Why we built Avail really is, we understood that there was this shift in blockchain architecture happening both at Polygon as well and with Avail, in the sense that the era of monolithic blockchain architectures was going, right? Even if you see blockchains like Solana, even they are experiencing congestion. With apps on the internet don't really live on one big supercomputer. We don't think in blockchain all apps will live on one chain. So it's necessarily going to be this single base layer, thousands and millions of rollups on top. So it's very similar to how the internet works, in the sense that apps live on their separate servers but scale independently on demand. And so that is the rollup centric paradigm that we are building Avail for. So Avail is really the infrastructure that powers the future of blockchains really. And so that's how we are looking at it, for example. So first we of course start with enabling these rollups to scale. And of course, we work with Polygon and various other rollup stacks to enable this. But really the intent is to kind of enable this rollup centric roadmap, and essentially, like, if you kind of step back a little, why are we building all this infrastructure for, right? Like, all of this we are building in the service of building truly scalable trust systems, right? Like, blockchains are the evolution of building trust systems. And so Avail really is trying to build infrastructure for enabling that root of trust in that sense. So of course we are very excited for releasing Avail DM mainnet, but we have things like Avail Nexus, which is our the upgrade that we announced, which we are working for last year. This is a layer that focuses on interop or chain abstraction sort of a interface between rollups that is coming up again, and pretty complementary to what Aglayer, which Polygon is doing.
Cool, nice. So I think people don't really realize this, but there's rollup technology is on the market, but this is a pivotal moment, I think, with the new CDK Aglayer release and Avail hitting the market in about May, like with stable releases. This is gonna like be a game changer again in this technology, like another strong move to ZK technology. Yeah, so I think one thing we really appreciate at Gelato, especially working with liquidity providers and so on, is the power of ZK technology, basically bringing settlement times down from 7 days to 30 minutes. I think a lot of the big unlocks in ZK, when I talk to, for example, the team at Espresso and so on, they all seem to go towards this instant proving, right? How far out are we from that? How is Polygon, like I know you guys are building all the software, like the ZK EVM software. Are you guys working also with hardware acceleration teams and so on? Like how, in 2 years from now, will proving time on CDK be like 5 minutes, instant? What can we expect here?
On the hardware acceleration side, we started a lot of work like in 2020, early 2023 only, and what we realized is that by the time hardware acceleration results came out and they built the hardware acceleration system, by that time our software acceleration went beyond what hardware acceleration was doing. And so we realized is, even though we have like still 1 or 2 parallel projects on the hardware acceleration going on, what we realize is that there is a lot of software enhancements and acceleration that you can do for now. And ZK technology is changing very, very, very fast. So there is no point in investing like long-term like hardware acceleration as of now, especially with these ASICs and all that. It's like, ASICs have a 1-year cycle, right? So ASICs work on Bitcoin because like the Bitcoin like SHA-256 and all that has not changed for last, 10 years. But with ZK, like, every 6 months, it is like a complete overhaul, right? So it doesn't make sense to go for ASICs, but maybe some works with FPGAs can be done. And that's what we are exploring right now, because FPGAs are like little bit programmable, hardware, kind of assets or acceleration systems. So like right now, like we decided that, we are not going to go fully deep into the hardware acceleration, but, keep the software progressing at space. And when we think that, okay, now it's approaching kind of maturity levels, then go to the hardware acceleration side. Having said that, like about the proving times, I think proving times, we want to like, our internal target is to go to like, let's say, proving times going to like 5 to 10 seconds, right? Like initially, we can't say like instant proving as of now, but right now we think that we have a path, I can't really say like 10 seconds or 30 seconds, but we have a path to go to 30 seconds, but we can easily have a path to go to 10 seconds also. That's what we are thinking. But basically you need this proving for composability, right? Interchain composability. And, no matter how fast it is, it will still allow this asynchronous composability, right? And for synchronous composability, then you need this shared sequencing and all that, which we believe that, there'll be like thousands and thousands of these chains. There will be some clusters with shared sequencers where, those clusters will have like synchronous composability. But otherwise, like the larger ecosystem will be like, as Anurag was saying, that you have each application has its own servers, and they can interact with each other with various different kind of systems. But there will be asynchronous composability. For synchronous, I think right now it looks like shared sequencing is the only way.
Yeah, I think Egg layer with its asynchronous ZK cross-chain settlements is basically 90% of the way, and then the extra 10% is maybe shared sequencing, and then we have the absolute end game. So yeah, thank you very much, Anurag and Sandeep. We're all looking forward to use this technology once it's stable and hits the market very soon. Decentralized data availability and Polygon CDK roll-up stack with ZK technology is going to melt faces. So excited for that. Happy to be working with you guys. Have fun tonight here. And yeah, the next panel is on Bitcoin L2s, and we have some real Bitcoin L2s here. I think Bob is here in the house with us. They launched today or announced. I think ZK BTC is in the house and Bitcoin Wallet as well. So that's the next panel, and then it's pizza and drinks from there on out. Thanks very much for coming. Yeah.
Thank you, everyone.
Thank you.